In this lesson, we're going to be starting on chapter 3, the molecules of cells. So in this chapter, we're essentially going to be building upon what we talked about in the last chapter, the chemistry of life, right? And really just applying the chemistry, what we learned about bonds and atoms and elements, and applying them now to biological systems. So it was important that you understood that material before moving on, or else it wouldn't really make sense to understand how to apply it to biology if we don't know the chemistry behind it. So we learned last chapter that molecules are made up of different elements, right, all put together. Um, Biological molecules are also known as organic molecules, and these are molecules that have to do with the building of living things. And one of the major characteristics, probably the most important thing to recognize about biological or organic molecules, is that they are made up of carbon. So the presence of carbon doesn't make something an organic compound. However, all organic compounds contain carbon. Right? So if it's an organic compound, it has to have carbon. Carbon can then be bonded to other molecules. Carbon is usually bonded to other carbons, hydrogens, right? But we're going to see that the presence of different molecules that are bonded to that carbon change the way the molecule behaves. Carbon can form up to 4 covalent bonds. And if you think back to, again, last chapter, we learned that a covalent bond is the sharing of electrons. Okay, so if we have our carbon atom, and carbon contains 4 valence electrons, right? So remember, those are the electrons in its outer shell that are involved in chemical reactions. This carbon wants to bond and wants to kind of, get rid of those electrons or share them in its outer shell. So, easily it can bond to hydrogens, right? So if you recall, hydrogens all contain 1 electron in their outer shell. So that works out nicely so that each of these hydrogens can bind to a carbon. So one way that we kind of find carbon in nature is bound to 4 of these hydrogen atoms, right? So this makes the simple compound, the simple organic compound, CH4 carbon and then 4 hydrogens, right? And this is also known as methane, which you may have heard of methane gas, right? So CH4, you can see that that carbon is bonded to 4 hydrogens, okay? But the carbon doesn't always bond to 4 hydrogens. It can bond to other molecules as well, and you'll see the vast array of organic compounds that exist. Carbon can also be bonded to these other molecules called functional groups, which we're going to see in a second. So when carbon is bonded to these different functional groups, then they have their own properties that contribute to the organic compound. So we're going to look at those functional groups. So there's different ways that we can represent a carbon organic compound. And we're going to look at these in lab. So we can write it in its structural formula and showing our carbon here bonded to 4 hydrogens. These lines represent single bonds between carbons and hydrogens. We can look at the 3-dimensional ball and stick model of carbon bonded to hydrogens, and it shows you the different angles of the bonding. And then sort of a more realistic space-filling model of the compound. So these are just different ways of representing CH4, which we saw on the previous slide, is carbon, again, bonded to 4 of those hydrogens. Okay, so I mentioned that carbon can actually be bonded to things other than hydrogens, right? And other than carbons, just carbons. And those different things that carbon can be bonded to are called functional groups. You are going to have to recognize these functional groups. I'm not going to ask you to memorize them or write them out in a sense, but if you saw them in a multiple choice situation, you would need to recognize them. So the first group that carbon can be bonded to is called a hydroxyl group. And a hydroxyl group is just an oxygen and a hydrogen. Okay, so hydroxyl groups are oxygens and hydrogens. So you can have a carbon molecule with an OH coming off of it. I'll show you an example in the next slide, kind of what a full molecule looks like. But carbon with a OH associated with it. That's a hydroxyl group. And these types of molecules are alcohols that are associated with hydroxyl. The second one is a carbonyl group. And a carbonyl group is a carbon atom double bonded to an oxygen. Okay? And then some molecule attached to it. Carboxyl groups we're going to see frequently because these are associated with carboxylic acids. And a carboxyl group is a carbon, two oxygens, and a hydrogen. Okay. And if you see this in an organic compound, it would be a carbon double bonded to an oxygen and then single bonded to a hydroxyl group. Okay, so this is a carboxyl group, and these are associated with molecules called carboxylic acids. And when we look at amino acids later, we're going to see that the carboxylic acid group is bonded to an amino group. And that's where the name amino acid comes from. Again, carboxylic acid. Amino group. This is the only group that has a nitrogen in it that we're going to talk about. And the amino group is a nitrogen and two hydrogens bonded together. And it looks like this when we're talking about it in an organic compound. NH2 amino group. And again, these are associated with amino acids, which are the building blocks of protein. Phosphate groups we're going to see associated with DNA later on in the year, but phosphate is a little bit more complicated. But you can remember it's got a P in it, and it's the only one that has phosphate actually in it has a P as its chemical symbol. You can remember amino group has an N in it; it's got a nitrogen in it. Phosphate, an oxygen, a phosphorus, three more oxygens. And this has a negative charge, -2 charge, indicating that it has gained 2 electrons, right? But don't worry too much about that. And what this would look like in an organic compound would be the oxygen bonded to a phosphorus, double bonded to an oxygen. And there's 2 more oxygens here, and then there's our negative charge. Okay, so this is a phosphate group. And again, we see these associated with DNA molecules. And many other, if you go on to take, AP biology or something, you'll learn a lot about phosphorylation and what it means. But in this class, just recognize what a phosphate group is. Okay. And then the last one is a carbon that is bonded to another carbon and 3 hydrogens. And this is a methyl group. So these are the different functional groups that, like I said, that are associated with organic compounds. Okay, so again, here's our hydroxyl group, OH, and you can see that it's associated with this two carbon molecule. This is an alcohol because it has that OH in it. Carbonyl group is a carbon double bonded to an oxygen. You can see one here, you can see one here. Carboxyl group, there's your C double zero H, so COOH. Here's a carboxylic acid. Don't worry about the ionized form. Amino acid, NH2. It's the only one that has that nitrogen in it. Phosphate group, the only one that has the phosphorus. So you can see an organic phosphate here with three phosphate groups attached to it. And then we've got a methyl group, CH3, here associated with this compound, which has been methylated. So the checkpoint question, identify the chemical groups that do not contain carbon, right? So hydroxyl group does not. The amino group does not. The phosphate group does not, right? All the other ones have a carbon in them, but these groups are attached to carbon-based molecules. So you want to be able, like I said, to recognize these in a multiple choice situation, these different groups, and we'll do some practice with it later on as well.